Hi, I'm Dennis Taylor, and welcome to the session Formulas and Functions, Part 2. In this session, we'll be talking about the VLOOKUP function, also the match and index functions. They're going to be needed sometimes because although the VLOOKUP function is extremely powerful, it does have some limitations. We can't always look leftward, and the VLOOKUP function is designed really to look up information in the left-hand column of a table and then look rightward to pick up other information. So match and index have a major role to play in the lookup concept of things. We'll also be talking about the COUNTIF and SUMIF family of functions. There were some major additions to that in 2007. Not everybody's up to speed on those, and those are pretty powerful tools for extracting information from large lists. We'll also talk about the importance of rounding functions. These are particularly important in financial situations, and some real horror stories have occurred when people have not rounded. Actually, they've just changed the visual display, and they've run into some real problems there. We'll talk about those. Excel has some really strong capabilities when it comes to handling dates and times, and there are some specialized functions associated with those, like extracting the day of the week, or calculating how many working days between two dates, or setting target dates into the future. Also a great feature called date diff, which has a bit of oddness about it because Microsoft doesn't really document it, and yet it's there and available to us, and it's ideal for calculating birth dates, ages, and anniversary type dates. There are some text functions. They're going to assume a lesser role in the future because of a new feature called flash fill, but we need to talk about some of those as well too. A new function in Excel 2010 is called aggregate, and it's a great tool, and now we have the ability to summarize information and overlook the errors that might exist in a list. That's an ideal use of aggregate. I will be using Excel 2013 in the presentation. Nearly everything we do will work in all prior versions, with the exception of a couple of new functions that we'll be talking about that only exist in Excel 2013. And those are functions called isFormula, formula text, and Arabic. Also, there's a special kind of formula called array formulas. They're real power tools, and sometimes you'll need to use those in combination with match and index when you're trying to match up information from different lists. There are specialized functions that are array functions as well. Frequency is one of them. Trend and growth you might have seen before. Also a function called transpose. And if we have time, we'll try and get to some other functions as well. I will not be covering financial functions. Many of you are in the financial arena. Those are going to be covered in a different course. And there's a large list of them as well too. And it is a reminder too as we get started here, when you click the Formulas tab in the ribbon, in all recent versions, you do see a list of various function types up here. Now, who has the time really to, click this and start looking at some of these and say, well, gee, I wonder what that one is? Most of us don't do that. Recognize, by the way, that the category called More Functions actually opens the door to one category of functions that I guess I thought was a lot more used than maybe Microsoft thinks it is, but under here we see statistical, and there's a ton of those there too. And some of you are familiar with maybe some of those, and there's a lot of them. So there's just way too many functions for most of us to know. Over 450. And let's face it, when was the last time you really needed inverse hyperbolic cosine? Now, I'm not trying to insult engineers out there. They might use that a lot. Others don't. So there are obviously a lot of functions here that are specialized for certain kinds of applications. Now you can also have nested VLOOKUPs. Now, that might sound a little strange, maybe a little advanced. It's not exactly advanced, but sometimes you're working with data and you need that situation. Here's a situation where we've got a list of, we don't even have the employee names, but we got employee numbers, and we're tracking gross pay, and we need to come up with the regional tax rate. Now, different states are in different regions here. And depending upon which region you are, you've got a different kind of tax rate. So here's someone who lives in Florida. Gross pay is $630. And what we're really trying to come up with here is the regional tax rate. So first order of business here is a VLOOKUP. take the state name, comma, and we're looking up the data in columns J and K. Now this time I will use the column reference. As always, when you are using column references, you want to be sure there's nothing else in those columns below this or any place else, just the data at hand if you want to be using that context. Comma, we want to get answers out of the second column. What we're looking for here is to come up with the region first. Once we get the region, for example, in Florida, and you can see over there that Florida is in the SE or the Southeast region, we need to get our answers out of the second column, so we put in a 2. This has to be an exact match. We can put in either the word false or 0. We do that, and I'll press enter. We should get an SE here, and we are. And we can copy that down the column and just check out a few of them. Here's Montana. MT is in the mountain region. Tennessee's in the southwest, Hawaii in the Pacific coast area, and so on. We see those. So we've figured out the region. But now we want to take that region and use it to come up with a regional tax amount. So we're not really concerned, by the way, about how much money people are making here, just the actual rate. So we're not really coming up with a full dollar amount here. So what we'd like to do is to use this SE in another VLOOKUP. In other words, this is going to be the amount we're looking up inside of another VLOOKUP. So right after the equal sign, we'll put in another VLOOKUP, an outer VLOOKUP. Look up what? Now remember, this is equal to SE. So we're trying to look up SE, comma, in a table over there to the right. And that table, scroll to the right a little bit, goes from column M over to column U. Now, that's a merged cell up there at the top, so our reference, actually it still works okay, M:U. So imagine, here's that SE. We don't see SE right now, but we're taking the text entry SE, looking it up in columns M through U, comma, and we want to get our answers out of which column here? Well, it's based on the number of dependents. Now, if you have 3 dependents in this table, it comes out of the 4th column. Now, looks like we don't have anything there for 0, so maybe we have to rework our table or something. But the point is, each kind of situation like this, you've got to rely upon the data at hand to make this work. So if you've got 3 dependents here, we need to take the dependents, that's out of cell E2, and since it's 3, but we really need column 4, this time we add +1. And it looks as if everything is in place. We do have to put in that final outer parentheses. So if you're in Florida, and that's the Southeast region, we figured out Southeast already, if you have 3 dependents, then the tax rate is 0.6%. And that's what we hope to be seeing. Now I've got 0.8, so let me revisit that. I possibly reread it. Now, when you are working with formulas and they're not coming up with the correct answer, you can evaluate them while editing. So I'm highlighting this portion of it here and pressing F9 to see that that's equal to SE. I'll press Control Z to undo. Okay, we're looking up the SE entry in columns M through U. We need to get our answers out of the column that's 1 greater than the number of dependents, but what I didn't do, and I didn't do this on purpose, by the way, we need this to be an exact match. In other words, in the outer VLOOKUP, we want to make sure that the SC is matching perfectly. So we put in a comma, 0 or false. And now we should have this correct. And it should be, in this case, 0.6, and it is. So if you're in Florida and you've got 3 dependents, remember it's the Southeast region, 3 dependents, there it is right there. 0.6. And we could copy this down the column and presumably get all the others correct too. Yeah, and from time to time we check those out. Now, admittedly, I made this table a little different than the previous one just to point out you can't always count on adding 2 to the number of dependents. I would think probably in the case here, there could be some logic that says if you've got 0 dependents, maybe it's a flat %, maybe it's not. But we probably would eventually adjust this table to have 0 dependents as well. But a VLOOKUP inside of a VLOOKUP, not unthinkable. And once again, The more you work with VLOOKUPs, the easier they become. They are widely used. They're extremely important in matching situations. But in some situations, we need to only find data. We only are interested in what we might call a match. Here's a different list, next sheet over. Now, imagine we've got a list somewhere. Now, this could be on a worksheet that's in a certain sense untouchable. You cannot change its layout, let's say. It might be in a different workbook. Let's say it's in this workbook, though. And elsewhere, you've got a Social Security number. Now, for ease of depicting what's going on here, I'm keeping this on the same worksheet as the data. I'll move it over here, readjust the column width. And by the way, the formatting for this, if I happen to double click it, doesn't really contain the dashes, and neither do these. And that's certainly something to be concerned about. What if you've got a Social Security number with actual dashes, and then you've got a list somewhere else you're trying to match up with it, and these don't have dashes? You're going to have to reconcile the two. Keep in mind that the data here doesn't really contain dashes. If you double click, you don't see them. And so what has happened here, whoever sent this to you, or maybe you in the past, formatted this. And by the way, when you press Control-1, you can see a format. What probably happened here was under Special, these were formatted as Social Security numbers, meaning the dashes are in the format, not in the content. Anyway, in this case here, this style, this format does match these. But imagine we're trying to find maybe only if this exists here. So what can we use? The function is called match, equal match. Now, in theory, you could use a VLOOKUP here, but this is going to be simpler and more direct. We've got a value right here, comma, and we're looking it up elsewhere. Where's the elsewhere? It's in column C. There it is, comma. And now, if we're trying to find a number that's closest to but less than, we'll put in a 1. If we're trying to find a number that's closest to but greater than, we would choose, or we would put in here a -1, which means greater than. If we want this to be an exact match, we put in 0. And this is part of the reason that I use 0 on VLOOKUP instead of false, because I want to have a consistency about 0 meaning exact match. Of course, that's not really logical to say 0 means exact match, but if we're going to use exact match here, our only option is to put in 0. Why not use it with VLOOKUP as well? So as I press return here, or enter, I should expect to see a match if that number's there. Some of you may have seen it already, row 13. We found it, and that's the answer we get. The 13 tells us it's in the 13th position of whatever range we're looking at. Now, if I had highlighted the cells like this instead, we're going to get an answer of 12, because it's going to be in the 12th position of those highlighted cells. So another strong reason for using column references, because the column reference, our answer, at least in this case, is going to be the same as the row number, and that just makes it easier to work with. So let's use column C here. Now, if you wanted to say and only say we found it, that's it. That's good enough. If I make the number be a different one, here's the kind of answer we'll get. NA. Now that doesn't read not found, but you quickly pick up on that idea. Now, depending upon circumstances, you could, if you really wanted to know whether you found it or not, you could use a function introduced in Excel 2007 called if error. If this is going to be an error, or if it is an error, comma, what do we want to display here? It would be more meaningful possibly to just put in a text string like not found. Now, if we do find it, it will perform the actual function. But in this case, because I changed the number, not found. And what happens when we do find it? If that is a 2, it simply goes about its business and does what it's supposed to do. And that makes life a little bit simpler. Prior to 2007, you would have had to have used the function called isError, and it requires restating of this. It makes for a much longer function. So this is handy at times too. Now, armed with that knowledge, you could say, really what we're after here is we've got a list of Social Security numbers. We want to go find their names. Well, VLOOKUP could possibly find this, but VLOOKUP doesn't let us look leftward. Now, a lot of people are saying right away, then why don't you just move the column A data over and put it right here, and then we'd be all set. We could find our number and then look to the right with the VLOOKUP. Well, let's just say that this data is protected in such a way that we can't control this worksheet. This is our master list, and either you or somebody else has control of it. We can't put new data in that column. In other words, we can't copy and use that data. And sometimes you're doing this with different workbooks where thousands of formulas are already working off the data. You just can't casually move the data around. So sometimes what we need here is another function called index. And in a bit, we'll show you how you might use that by itself, but sometimes we'll use index and match together. The index function is designed to pull data out of a list somewhere, out of a range. Call it a table if you wish, but we could say it that way. Index. We've got a table of data somewhere, or a range of data, say it either way. I've got data somewhere, where? In columns A, B, and C, comma. I need to get data out of a certain row. What row do I need to get data out of? For the moment, I'll just type 13, because that's what we got with the match. And which column do I want to get the data from? Column 1. I want to know whose name this is. And you can see ahead of time it's going to be Terry Malloy, and that's what we'll get here. Terry Malloy, right down there. So that seems a little complex. And of course, if we want to use this with match, we could do this a couple different ways. I'm going to pick up what? The answer that we got from cell F2. So I'll plug it in that way, and we'll get the same answer. And what we might do eventually is to simply highlight this. Now, we could use it in the longer version. Let's say in a real life situation, what we might really want to do to make it a little bit simpler here and not make it too complex at first, let's say we'll just do this for the moment. So match will tell us what? We found the data in the 13th position. Let's take that function right there without the equal sign. Highlight that portion of it, Control C to copy and escape. Let's plug it into here, right there, in place of that. Control V. So a match inside of an index. We will get a correct answer here. Now, a new function in Excel 2013 might help here too. I'm going to leave that there and make the column just a little bit wider. Now, this is handy probably more for people who are teaching than it is for others, but I'll use it anyway. It's going to be handy here. It's called formula text. Formula text. Equal, and it's so long as soon as you type FO, you'll see it in the list right here. You could click here and then tab it into place. What's the formula text of that? So it simply displays it here. Now, if I make changes to it or do other things, it's going to change. Now, here's what I'd like to do also. I'm going to simply repeat this. And as I do, I'm going to have to make an adjustment to the reference up there instead of match E3. That's going to be a match E2. There we go. Okay. Now, in this situation, we can simplify it even further. At the time we're looking to extract the data, in other words, when we're looking at think of the index function only for the moment. When we are looking, remember, all we care about is the name. Instead of looking in columns A, B, and C, let's just consider column A. Now that means column A only. The match will tell us it's in the 13th row. But if we're only looking at a single column, we don't need a column reference out here. So I'll delete that entry. And that makes it easier to read. And if I copy this downward, we'll see there's a depiction of the two formulas side by side. Obviously, the second one's shorter. So whether I double click here, I mean, you can still see it to the right, but recognize what's happening here. Now, any book that covers functions in any depth whatsoever, or everyone I've seen at least, anytime you see a reference to match, you're likely to see a cross-reference to index. And every time you see index, you're likely to see a cross-reference to match. It doesn't mean that they are always used the same, or used at the same time and together, but it's certainly common to see them together for situations like this. In effect, what we're doing here is a leftward VLOOKUP, and sometimes those are necessary. But it's simpler and straightforward, and once you get used to it, it's easier than you might think at first. Now, if both of these are relatively new to you, or say brand new to you, your head's probably swimming a little bit. It's like two new functions and then nesting them like this. But this would get the job done. And it's not uncommon to where you've got a list in one worksheet where you need to get data out of another. And again, to make another point here, if we do this from a different worksheet, so all I'm going to do here is a Control C on this and jump over to another worksheet out here somewhere. I'm just going to click here and put a Control V. So what if we had this on a different worksheet and we're trying to say who's that associated with? So we could do the following: equal match, left parenthesis, here's the item in question, comma, I'll go back to the other worksheet, look in column C, comma, I want an exact match, so I'll type 0 and enter. So we're at 13. Ignore the decimal, it's not going to hurt, but what are we looking at here? Maybe I'll use the is formula text off to the right too, so we can see that. Oops, I'm sorry, it's formula. I was thinking of another function there. Formula text, there we go. Tab it in, right there, enter. Okay, so that's the formula in place. Now, once we knew that, of course, we could then put in, and I'll copy this ahead of time too. I'm going to type equal index, left parentheses, where is the table we're trying to get at? It's on the other sheet. We jump to the other sheet. We select column A only, comma, and now I'm going to have to jump back to the other worksheet here and click this cell, and that should do it. Enter. Terry Malloy. Now, when you are moving back and forth, when I came back to this worksheet and clicked on the worksheet and then the cell, it put in the sheet name, but I can actually get rid of that because we're on the same sheet here. So that should work also. So it's just to point out that sometimes when you're doing these lookups, in this case with the index and match, we go to different worksheets where the lists happen to reside. And so this is working here. Notice how pretty straightforward it is. It's the equivalent of a leftward VLOOKUP trying to match up data in a different worksheet. So it gets pretty involved at times. I say too, the longer the sheet name it is, I wouldn't say it's bad because you want your sheet names to be explanatory if at all possible. But the longer the sheet names are, the longer the formulas tend to be. It's not always by itself intrinsically bad, but when you've got indexes and matches and VLOOKUPs across multiple worksheets, when you've got worksheets that got 20, 25 characters, whatever, they sometimes look more difficult than they really should be just because of long sheet names. Now, there are other situations, and then we're going to come back to a few of these matches later. Let me alert you to this ahead of time, but there are certain kinds of matches when you're matching, particularly across different worksheets. When we got data split into separate columns, what if you were saying, I want to know what Susan Carr's salary is? Now, here's a list here where the names are split into separate columns. And then we've got our list that we're trying to match up. Now imagine this is possibly in a different worksheet. To make it visible so we can see the two side by side, I put them in the same worksheet. We know what Susan Carr's salary is ahead of time. It's $69,000. It's right over there. But how do we pull these together? How do we do this matching here? And even more difficult, how about a situation over here? Here's Juan Garcia. What's Juan's ID number? And we can look to the left there. So we're going to come back to this a bit later. We do need to introduce a new feature for at least the second part of this. What I might do right now is actually do the situation on the left, because I want to introduce another feature, another aspect of working with data that we can do here. So here we see Carr and Susan, but our list to the right has the names in reverse order. So how do we construct, in effect, Carr, comma, Susan? Let me do just that part first. You can do this in two ways. There is a function called concatenate. This is not my preferred way of doing it, but recognize that it's there. And every time you use this word, you have to you know, explain to everybody how to spell it and what it means. It means pulling things together, or as the pop-up tip, joins several text strings into one text string. So concatenate, and I'll just tab it into place. Concatenate what? So trying to match up with the list like we see it on the right, we want to pick up the last name, that's A2, comma, and now within double quotes, we want to put in a comma and a space, because in the names over in column F, that's what we see. We see a last name, then a comma space. But that needs to be embedded within double quotes, and then another comma, and then pick up Susan. So when I press enter here, we should be seeing car, comma, space, Susan. And there it is. So that's what we want to match up. Now, let me leave that there, or actually what I'd like to do is I'll put a space in front of it and simply pull it down here for the moment. Now, the other way to do this, which I find better, is equal, and then we'll pick up the last name by clicking there, followed by the ampersand, the and sign. So we want to, it's as if we're saying, let's go get car and double quote, comma, space, double quote, and let's go get Susan. We'll get the same answer we saw before, and double clicking to compare the formulas. To me, that's easier than concatenate. Now, again, I recognize they both work, and you know, try one, try the other, and it certainly is less space. That's not always the best reason, but we see what's happening there. But once we know that we've got this capability, then we can start making our comparisons. So I'll use the one that's on top, the one I just created, and plug that into our formula. So let's say we want to do a VLOOKUP with what? This entry right here. Now remember, what that consists of, what that means right now, that's car, comma, space, Susan. That's what we're trying to use. Comma, we're trying to look that up in a table, and eventually we're trying to get the salary. So for purposes of table lookup, we want to highlight columns F and G, comma, we need to get our answers out of the second column of that table. So that's column G. So we put in a 2. And this must be an exact match. That's 0 or false, either way. All set here, enter. And we got our match, and that's the salary. Once again, here's what we're looking at. So certainly tricky, at least at first, but remember, all we're doing here is building, or rebuilding, you could say, the car and the Susan, which are in different locations. We're putting them together as car, comma, space, Susan to match up with the kinds of formatting that we've got over in column F. And when these aren't working, we will have some of these aren't working okay. In other words, there is no Alan Forrest over there, presumably. So we could look up and down here and not find Alan Forrest. Not there. And that's what's going to happen, and that's believable. The others we found. And you can check out this one. Here's Carol McGee right here. That's the one that's second on the list. 65,560, we see her salary. Now, we're going to come back a bit later and tackle this because that's a lot trickier. How do we compare Juan Garcia with the list over here where the names are in different columns? That's a little trickier. So we'll come back to that. All right, let's shift gears a little bit and talk about some functions, a few functions that have been around since Excel 97, but some additions to that family of functions called COUNTIF. Here's a worksheet here that has a list of names, and the question has come up, maybe just in passing. Somebody says, how many full-time people do we have? To make this more readable, what I'd like to do is just hide some columns that we're not going to be needing. I'm going to hide these right here. Right click and hide. And actually I could have hidden, I'll hide the bonus column too. And make column Q wider. Okay. So I've got some of the text set up ahead of time here. Somebody has asked the question already, well, how many full-time people do we have here? So column H, and I'll double click the bottom edge just to remind you how much data we have here, goes down to row 699. So we've got 698 people here. How many full-time people do we have? In other words, let's count how often we see that phrase full-time over in column H. And here's the function, COUNTIF. Pretty easy, pretty straightforward. Where are we looking? Once again, whole column reference is going to work well for us here. Column H, comma, and what are we looking for? So we can either type double quote full-time. Since I do have it in the cell to the right, I'll just pick it up from there. Makes it simpler. And I'll press Control Enter here and simply double click. And we'll have the other entries too. Fast and easy. And what do those add up to? In our status bar at the bottom, it says 698. Well, that's how many entries we have over in column H. So everything's accounted for. Very simple, very straightforward. If we wanted to know the salaries of all those people, just by adding them, we use SUMIF instead of COUNTIF, but SUMIF has an additional argument in it, and it follows the other two arguments. In other words, we're still saying go find the full-time people, but when we do, let's go get their compensation or their salaries out of column L. Now, if you're using exact addresses, this list here and this list here must be parallel. If that said H2 colon H500, this better say L2 colon L500 or something of that nature. In other words, we want these to be in parallel. And when you use entire column references, that's just fine. So the amount of money we're paying the full-time people is that. Once again, we'll double click and probably format them. Control Shift exclamation point would be one fast way to get there. Our total in the lower right corner is 43,324,000, etc. If we click column L, it's going to be the same. We see the same number down there. So that's a SUMIF. So we've got COUNTIF and SUMIF. And in 2007, there were 4 new variations introduced. Everybody kept saying, where's average if? And so what a lot of people did before this was to take a SUMIF and divide it by a COUNTIF. When we use average if, as you would imagine here, it's going to be the same idea, but now we'll just get the average salary. So there it is, and I'll double click here and so on. Or average compensation is the better term there. So we get that. But sometimes what we want to do is use multiple criteria, and if we had to do this in the past, we'd have to use something called an array formula. So there are 3 new functions: COUNTIFs, SUMIFs, and average ifs. Start with the COUNTIFs. This allows multiple arguments or multiple parameters, as you prefer. Plural, meaning we can have more than one criterion, more than one criterion. In other words, multiple criteria. So here's the idea. If we only wanted to look for full-time, we could use this. That we wouldn't need to use it, but that would work. In other words, we're looking in column H for full-time. But what if we extend this? We want to know how many of our full-time workers here have a job rating of 5. So we're looking for 2 multiple sets of criteria. They both must be true. First one is they've got to be full-time, and now, comma, we're looking at the job rating. Those are in column J, comma, and we're looking for a 5. If it's a text entry, by the way, you'd have to put these in double quotes. We're looking for a 5. So how many of our full-time people here have a job rating of 5? 97. And we'll just double click and copy it down, and then we've got 19 of our half-time people, 11 of our hourly people, and 38 of our contract people. So multiple criteria. And we can have up to 31 criteria pair here, if that's the phrase. There's no real terminology existing here, but that's one pair, and here's another. Well, maybe add a third. How many of our full-time people who have a job rating of 5 have more than 10 years of service? Comma, years, comma, but how do we say more than 10 years or 10 or more? Within double quotes, greater than, equal to 10, double quote. There we are, 65 of them. And what had we seen? It was 97. Okay, and we'll double click again. So looking at this, 3 criteria pair here. Got to be full. We're looking for all people who are full-time and their job rating is 5 and their years of service is 10 or more. All 3 criteria. And you can imagine how we use this with SUMIFs and COUNTIFs. But here's a little wrinkle that might upset you a little bit. If we switch this to an average ifs or a SUMIFs, what we do in either case, first of all, I'll make the word change. I'll use average here. Here, the sum comes, in other words, what we're tabulating comes first. Now, earlier with an average if and a sum if, what we tabulated came last. So let's say what we want to know is the average compensation here. We're going to plug that in first. I'm going to click column L, comma, and then we've got, first criterion, second criterion, third criterion, and so on. So what's the average salary of all of our full-time people with a job rating of 5 who've been here more than 10 years? There it is. And there too. By the way, if you want to use general format here, Control Shift tilde for that. Now it does show the decimals in this case, so you might want to use Control Shift exclamation point. There we go, and double click, something like that. So at different times, these are going to come in really handy. And by the way, you can also use wildcards in here. One example could be. Let's see, anybody who's full-time or half-time. What if we just wanted a count of those? I'll use a simple example here. We'll just go back to a count if. So in this example here, let's strike all that. We're looking only in column H, comma, and I'm looking for anybody who's full-time or half-time. So how might we do this? What do those names have in common? The word time is in both of them. So we could use double quote, asterisk, time. And in this case, we don't need a trailing asterisk, so that should work, but a trailing double quote. And so ignore this word to the right for the moment. We've got 468 people who have the word time in their status entry. That's one way to say it. Different way, of course, is anybody who meets either of those two criteria. We're counting all entries where the word time appears in column H with a wildcard there. I think putting an asterisk behind the E wouldn't hurt, but I'm going to try that. I haven't tried that recently, and we get the same answer. So that covers other bases as well, too. So that if you were looking in a different way, in a different context, we could find out all the people named, James, but we would also find the people named Jameson, or it contained James or something. So other uses for that as well too. Getting close to some of the things we might do with a filter. Now, another category of functions that's really important too at different times is what we call rounding functions. And there's a huge mistake that people make sometimes when they use formulas. They create answers, and sometimes the answers have decimals in them, and they might use the simple rounding buttons here. These are on the home tab in the number group for displaying either fewer decimals or more decimals. Let's first start with an example here of something that seems to be all in place, and yet we get a strange answer here. Here's what's happened. In column A, we've got some item numbers. We don't care about those. But in column B, we've got the price of these. And it turns out that these items are all going to be increased by 4.36%. We haven't increased these in 5 years, due for a price increase. All these items, here's the current price, and here's a formula to increase these by 4.36%. Pretty straightforward, pretty simple, like a salary improvement change, something like that. So thinking of these numbers, and imagine that maybe that's a piece of office equipment or something, a rubber bands or box of pencils or something, pens. Okay, somebody orders 10,000 of these, some big company, equal 10,000 times this number. We know the answer is going to be 90,000. We can do the numbers in our head and press enter. Well, that's not the answer. Now, it's not off by a huge amount percentage-wise. What's that, $41.68? But that money either goes somewhere or gets lost somewhere. What's going on? Well, why is that not, isn't that 9 times 10,000? Well, as it turns out, in this formula here, probably the person who did this, let's say, saw the price over here. That's 8.62. Come up with the calculation. Looks like $9. Well, let's see what happens if we actually display more decimals. Now, here's what can be misleading, and this is why sometimes people make a mistake with this. When we increase the decimal, I always want it to say show more decimals, or the button to the right, show fewer decimals, because that's all we're really doing. And as I do this, we're going to see that the real answer here really isn't $9. It's $8.99.5832. And as I do this, the answer to the right, the calculation will not change. And what does that mean? We are not changing the value of this. We're going to change the display of this by increasing decimals. Notice nothing's changing to the right. Here's the real answer. And possibly the person who wrote the formula, maybe, I doubt if the person ever saw this number. If he or she had displayed more decimals, might have seen something like this, but I've heard it said, I've heard people say, well, just round this off. Let's just, decrease the decimal. Okay, looks good. We're all set. No, you're not, because you really didn't change the value. You simply changed the display. So what should we do here? First of all, let's show the decimals so we know what's going on. All right, I'm going to change this by putting in the word round in front of this. Now this will change the result for sure. The round function allows us to round to any number of different decimal places. If we want to round this to the nearest penny, that's 2 decimals to the right. So we put in a comma 2 at the end here. Now as soon as I press enter, we're going to see $9 with all those zeros, and the formula to the right will adjust immediately. There we are. So there's the real answer. And of course we wouldn't leave it displayed like that. But that's what's happening here. We got to put in the round function. Now, I'll just copy this down the column and we see the others too. And of course, eventually just decrease the decimals. But we want to consider some other options too. Sometimes when you're rounding, and I think you know here too, without me telling you exactly, that when we round here, we go to the nearest penny. We round to 2 decimals, the nearest 2 decimal places. So it's quite possible in some of these cases, we went downward a little bit. What if we always want to go up to the next penny no matter what? So I'm going to put in a different function called round up. Didn't change the first one. Will it change the next one? I'll drag it down to there. Didn't change that one. Next one? Yes, it did. That went up a penny. So depending on whether you use round or round up, we might go in different directions here. And as you might guess, there is a round down. Now that's going to change our first entry to be 8.99, and our formula to the right is going to change as well. So that's a round down. And an easy way to remember that is what we do with our ages. If you are 39 years and 11 months old, how old are you? You're not 40, you're 39, aren't you? So we round down with our ages. Unless you're 6 years old or something where you might say, I'm 6.5 or whatever. But, or 7. Anyway, we see what's going on here. So round up, round down, needed at different times. There could be situations where you want to do a different kind of rounding. What if it's important to you that all your prices end in a 9? We've seen that in some stores maybe. You want all your prices to end in 9. So what we could do here is, let's just do a simple round. Now we could do up or down, but let's make it a little bit simpler at first. Let's round these to the nearest 10 cents. That's 1 decimal. Now that doesn't quite get us there, but that takes us to the nearest 10 cents. You see those answers. But what are we going to do now? Subtract a penny. Minus 0.01. And I'll do all those at once. So those all end in 9, if that's important to you. And, we see some pricing where it does something like that. In the book industry, a lot of prices, book prices end in a nickel. So there's an option for handling that as well too. Now, what if it is important to round these to the nearest nickel? You can use another function called mround. Mround allows us to a multiple of anything we want. So for example here, if I want these to be to the nearest 5 cents, 0.05. So those are to the nearest 5 cents. Now some of those would have dropped maybe 3 or close to 2.5 cents, something like that. So if you were guessing, the companion here for going up, you probably would think would be M round up, and then the down, M round down, but nope, that's not the case. It's going to be, believe it or not, ceiling. So if you need to round up and you're using not a multiple, not a decimal amount, we could do this. This is going to go up to the next penny. And so the next entry, I'm not sure if it's going to go up, probably won't. The one after that might go to 440. Not yet. There we go. That went from 810 to 815. Next one is 660, stays the same. 510, that went up to 515, and so on. So you can begin to see these. Of course, once you know ceiling, you know what its opposite is going to be. That's going to be floor. So M round, ceiling, and floor are companions, as are round, round up, and round down. And we can use these in other contexts as well here too. And here's another thought. What if you want your salaries to be, and I've seen this done occasionally, not a whole lot. What if you want all your new salaries, here we're calculating new salaries based on a 2.43% increase. What if you want all your new salaries to be to the nearest dollar? That's certainly reasonable. Let's round these, comma, zero, nearest 0 decimal places. So it's looking like that. So I'll just drag a few here to make sure we see those. We're rounding these to the nearest dollar. I have seen salaries where they're to the nearest $100. Now, the people getting the increase probably don't want to see that exactly, but if we want to round these to the nearest $100, we want to move 2 characters to the left of the decimal, 2 places to the left of the decimal. So we put in -2. Let me do just the first one. So the next one you can see ahead of time is going to go to 200. The next one after that is going to jump up to 600, 78,600. It's going to go up $38. And here too, of course, we could use round up and round down. Here's another thought. I was working with a company once, and I recognized that their gross pay amounts were always an even number. And what they did, since it was a biweekly pay every 2 weeks, they made sure that their biweekly pay was a multiple of 26. So they used M round, and instead of a -2 here, they used 26. So this is going to be a number, it's to the nearest $26, and that means it's a multiple of 26. So if we were to take all these numbers here, we can do it real fast this way, equal this and divide it by 26, we see that the answers come out even. And if you had a twice a month payroll situation and you wanted to make sure that your gross pay every time you got paid was a whole number, you would use an M round with a 24. So there are all kinds of creative uses of these. But the key thought behind all these rounding functions is they really do change the results. And you need to be aware of that at times. A real simple example here showing you how absurd it is to just do formatting is something like this. I'm going to put in 4.6 for all of these and put a total below them. I'll just press Alt equal. Okay, so imagine somebody saying, well, we don't really need to see the decimals here. Let's decrease the decimals. Okay. Obviously, that's not acceptable. 5 times 5 is 23. What is this, some kind of new math or something? Well, what's going on here? Excel isn't making a mistake. Well, we know these aren't really 5s. We simply changed the decimal display. Double click. That's a 4.6. And of course, that explains why we got this total. So you got to be on top of these issues. Never, never use these buttons here to say that you're changing the result. You're simply changing the display. So we got to use rounding functions at certain times. Now, Excel is great at handling dates and times. And there are a couple of functions here that you probably would want to know about. Now, one here, it's a little annoying the way this works, but at the same time, imagine how important it is to know day of the week. Now, how about a mythical situation? Maybe this is a realty company. Business has been a little slow. They haven't sold too many, but every so often, maybe it's commercial, so they don't have too many sales that often, or maybe it's a company that sells heavy equipment. On what day of the week were these sales made? And of course, you could imagine a situation where we've got tons of transaction data. We want to know day of the week. It's going to help us analyze our business. Equal weekday. And the answer is a bit disappointing. 4 means Wednesday. 1 is Sunday, 2 is Monday, etc. 7 is Saturday, and all that. Anytime you use this, it seems like almost invariably you want to jump right into Format Cells. Control 1, go right to Custom, and pop in either, in this panel right here, it says General right there, the upper part, type in 3Ds or 4Ds. 3Ds will simply display the data, for example, as WED. 4Ds will display it as Wednesday. There we go. If we copy this down the column with a double click, we see all the others too. All of these, of course, are using the weekday function. It's ultimately great information depending upon how you work with dates and times and how important it is to recognize what day of the week means in your particular business. Now, sometimes we want to know working days or time elapsed between dates. Keep in mind, if we simply want to know how much time has elapsed between these two dates, we can subtract the two. You can subtract dates equal a later date minus an earlier date. 106 days. That's it. But how many let's move this over here. How many working days was that? Here's a function called net work days. As soon as you type N, you're likely to see it right away. Just click it and tab it into place. Makes it easier. Here's our starting date, comma. Here's our ending date. It was only 77 days. Now, it does allow for holidays too, but this is counting only Mondays through Fridays. Let's move that over here for the moment. For holidays, you've got to have a list of holidays somewhere. And we don't have to highlight them all as we use this, maybe just the relevant ones, or we can overlap. That's okay too. Let's do this over again. Actually, I'll just make a copy of it and put it back. Well, let me do it over again. Equal network days, N, there we go. Click, tab, starting date, right there, comma, ending date, comma. Either select all or at least the relevant dates from that list over there in column D. I'll simply drag across a bunch and we get all the ones covered. That's good enough. And enter. Instead of 77, it's 74. And Excel does this right too. If, for example, if July 4th was a Saturday, it wouldn't discount it twice. So there were 3 holidays involved there, the 3 summer holidays of Memorial Day, July 4th, and Labor Day. So it's 74 instead of our earlier answer of 77. So that's easy to work with. Sometimes you're going the reverse. You're going to start a project in November. A couple months out, November 3rd, it's 45 days long. If we simply want to know 45 days, it's the starting date plus the number of days, and that's going to give us an answer. But we know there are a lot of weekend days there, and of course, there are a lot of holidays too. Let me move this over here. How about work day? Left parenthesis. Here's our starting date, comma. Here's the number of days we need, right there. Let's just do the Saturdays and Sundays, or skip the Saturdays and Sundays first. We're going to be finished there. Now, when you get a number like this really throws you at times when you work with dates and times. Some of you know what's happening here. This is actually a date number. And you kind of get used to the idea that numbers are, anywhere from 38 to 45,000 are probably going to be in the current time frame. We want to display these as a pure date. All you need to do in this case, click on a date nearby, and with the right mouse button, drag this on top of this data, let go of the right mouse button, copy here as formats only. So 45 days, not counting Saturdays and Sundays, starting November 1st, it's going to be right here. If we include our holidays, of course, it's going to be simpler. Workday. Here's our starting date, comma, here's the number of days. This project begins on November 3rd. If it's going to take 45 days, we don't work Saturdays and Sundays, and we want to not be sure we're counting our holidays. Let's just highlight the relevant cells over there. Oops, I overwrote what I wanted to do there for a second. There we go. There's our 45 days, comma, and there is the reference to the holidays. So instead of finishing on the 5th, now we got the same issue. I'll simply, with the right mouse button, drag this downward, and there's our format. So it's actually 8 days later than it was here, probably into another week. And of course, depending upon your holidays here, we get Thanksgiving the day after, Christmas in the day after, New Year's in the day after. And of course, depending upon where you work, that could be a different list. But you've got your master list there as we work with these two functions, workday and then net work days. So these are really valuable functions. Now, there's another function that's very strange indeed, but it's really an excellent function. And it's being used in this worksheet right here. I'm going to make the column a lot wider and zoom way in. The function is called dateDiff. Now, at the time of this recording, I'm in early September. So dateDiff says we got a date somewhere. and we're comparing it with another date. Now, many times when you're working with date diff, you've got two separate dates, but here we're using something that might surprise you. This is a function called today, which some of you are aware of. And right now, as I record this, it's September 4th. So here's a person hired in 1995. How long has this person been here in years? And we're not talking about decimals here. This person has been here, what, 19 years. That's why we see 19. Now, what if that person were hired in October? And at the time of this recording, this is a month from now, 18. Now, you might be saying, well, wait a minute. Isn't it almost 19? That's true, but it's not 19 yet. In fact, this works to the day. And so once again, as I'm recording this, it's September 4th. What if this person was hired on September 5th of that year? It's still 18. If I change that to September 4th, it will be 19. So this is accurate to the day. Now think of other scenarios where maybe this represents the birthday. This is today's date. How old is this person? Because that's how we calculate these. Or it's an anniversary date. Here's the starting date, the hire date. Here's today's date. We simply want to know how many years the person has been here. That's what we're calculating here. So let me undo those date changes, because what we also want to show you here is that sometimes instead of Y as the answer, by the way, that can be upper and lower case, but sometimes you want to know how many months. And this too does rounding in the same way. In other words, it doesn't count the month until it's fully completed. So 228 months this person has been here, 228 months ago. And sure enough, D for day, that's how many days. You probably wouldn't care about that when you're talking about hire dates and this sort of thing. And by the way, if you got a spare moment, try this with your birth date, your own birth date and today's date, and find out how many days old you are. You might be appalled or whatever. So different thoughts here. And by the way, just to make it kind of quick here, there are 3 variations on this. We can find out how many days it has been since the last yearly anniversary. So in this case here, I'm about 9 months away or so, but so this is going to be like 330 or 320, somewhere in that neighborhood. Probably more like 340 even, maybe. I don't know. Wait a minute, did I do that one? How many days has it? Okay, how many days has it been since the last year? There it goes. So that's actually looking the other way. So we're short of 365 days by 23 days. How many days has it been since the last yearly anniversary? Or how many days has it been since the last monthly anniversary? And so in some of these cases, particularly with this kind of an example, these are trivia. So how many days after the month? And a third one would be how many months has it been since the last yearly anniversary? So in the example here, YM, it's going to come up with 11. Actually, it's going to be none, sorry. The last anniversary was in just August, which in this case is less than a month ago. If this were October, remember I'm in early December. I'm sorry, I'm in early September. There we are. The answer we get here is 10. Anyway, those are worth looking at. And I think the more common example, as I used it here, was simply the Y. And we see that for the rest of the entries too. Now, here's the weird thing. Here's what's weird about it. I show that to you. Sounds good. You kind of file it away. And you need it in a few weeks, and you come back, maybe in a situation like this where you haven't plugged these in or anything, and you want to use that function. So you jump over here to the Formulas tab, and you go to Date and Time, and you say, what was that? Was it date value? Just see here. When was it? Eventually, you come to realize it's not here, and yet the function works. And you might have noticed here, well, if you were typing it, most times when you type in a function name, in the list here, you start to see it before long. But in this case, you don't see it. It never appears. An odd thing is, as soon as you put in left parenthesis, it says date diff. Now, if you did something like, if you just made up a name, you don't see anything below it. So it's kind of like a tiny little clue there that it recognizes it. So this is really strange. In other words, here's a function that works, and yet there's no documentation on it. And I could be typing it brand new right now and say, here's my starting date, comma, I want to compare it with today's date, and I want to know how many years it is. It comes up with an answer, and it works just fine, and it's accurate. Very strange. Now, what's also strange is that if you use Excel on the Mac, this is available and it is documented there. And you will see it in your list of date and time functions if you're using Excel on the Mac. So I have no idea where this happens. There is, by the way, a tiny flaw in it. It's almost trivia. I won't go into the details, but if you're trying to compare dates, say from the end of January into early March, and you're using the construction, I believe it's either, I think it's going to be MD, you will get, and there is a bug in there that they just have never fixed over the years. So that's probably why this isn't documented. But why is it documented on the Mac? We'll probably never know. Anyway, I think it's a great tool, and it's ideally used in this example right here. Now, Excel also has a category of functions here called text functions. And when you slide over these, a lot of them seem like trivia, and in a certain sense, maybe they are. They allow us to extract data from cells, usually text entries. And a broad use of these is likely to be overridden by a new feature in Excel 2013 called Flash Fill. But let's take a look at some situations here. We've got some names in column A. And I recall a scenario, it's not really a scenario, a real situation a few years ago. A summer intern for a company that will remain nameless was asked to retype a name, a list of names here, a list of 200 names where all the names had been capitalized. And we want to uncapitalize them, if that's the phrase. And we can do that with a function called proper. Now, proper doesn't make these all uppercase or all lowercase. It only capitalizes the letter that begins the entry or any letter that follows a space or punctuation. So if I simply complete this here, you can see what it's doing there, and as I double click, you can see what's happening. Notice it gets the B in O'Brien right, since that follows punctuation. We've got spacing issues here too. Notice how it gets the J and Todd Jones here. That follows a dash, so that works too. It doesn't do the D in McDonald the way you might want it, so you'd have to adjust that manually probably. But we've got all these answers here, and that's the way we'd want to see them. Makes good sense. Now, got another situation over here. I'm going to show you a bit how Flash Fill probably negates the use for many of these. We want all of our letters, in this case, to be uppercase, equal upper. This does nothing to the numbers, but it certainly is going to adjust our letters. The opposite of this, by the way, is not called downer. It's called lower, as you might guess. There we go. Double click, and those are all set too. Now, here's a question. How do you take the results here and keep them? In other words, throw away the bad entries that you've got. The standard technique for doing this involves copying and pasting 4 or 5 steps, but we can do this essentially in one step. Remember, these are all formulas here that work off the data in column D. I'm going to use the right mouse button here and simply drag this data on top of the old data. And when I let go of the mouse, copy here is values only. So what are we left with here? The data as we see it. And then we don't need this over here. Just get rid of it. So that's going to be handy and fast. And by the way, a common problem with data too much data in the same column, same cell. If this is next to other relevant data on both sides, we cannot sort our list by state. We can't sort it by zip code. Also, sometimes we need to pull data together. Now, we saw earlier the ability of concatenate to do this, but in all these examples here, we've got a new feature. And I'm going to show it to you here, and I think it's pretty amazing. You want to experiment with it at times. There are a couple of quirks, maybe. Here's the feature. I'm going to type this entry the way I want it to be. So I'm going to type Wagner, comma space Max. And then right here, I'm going to type B for Baxter. And immediately Excel says, I see what you're doing. I'll just press enter. We're all set. And we don't need any formulas. We could get rid. These are not formulas. This is new data. We could just get rid of column A. Maybe move the label over first. Get rid of column A. Over here, we had that. I didn't pull back the bad example, so we'll just leave it there. But if we wanted these to be lower, I mean, I really wouldn't want to do that. But what if I only want to pick up the 3rd, 4th, and 5th characters out of here, something like that? So that's going to be 0, capital Y, and a 1. So I'm typing that. And then here, I'm going to type that third character. It's also a 0. Excel says, I see what you're doing. There we go. So we pulled out that. And we could go to the right here too if we wanted to. I'm going to say over here, maybe I want to pull out 2 characters from the right. So I'll type a 94. Now, this is a number here, so this might not work quite the same. Now I'm going to type 0, and Excel does see it. Now, it won't display the 0, but it pulls out the 2 characters on the right of that data. There's another way to use this too. Let me backtrack for a second here. Another way to do this is, and it's not better, but it maybe it reinforces the idea. And actually, I think I'll go back to the previous example. Okay, so I'm going to type 0, capital, oops, get back here. 0, capital Y, 1, and Control Enter. And then on the Data tab, choose Flash Fill. And Excel doesn't ask any questions, do anything. It just does what it needs to do. So you can imagine here how this is going to work with the data here. We really need to split this data into 3 columns. And I wish it were a little faster, although it's reasonably fast. All I'm really going to do is type Boulder right here, and then go to the right and type CO, and then to the right 80304. Now, the way I'm going to try it here is to highlight these cells and go to Flash Fill, but it's not selectable. But if I select Boulder and go to Flash Fill, it works. Type C, or click on the cell with CO, Flash Fill, it works, and type the zip code entry, Flash Fill, it's all working. So it's pretty fast, you got to admit. And here too, we could get rid of the column G data, relabel this, we're all set. And with concatenation, it's going to work as well too. So I'm going to type right here, and I'm going to reverse the order of the column entries here too. I'm going to type Baxter, comma, space, Donna, oops, space A. And I could either start the next entry or try Flash Fill. I'm going to just do a Control Enter and try Flash Fill. There it is. Let me undo that. The other way of doing this is, after typing this, I can go down here. I'll type the last first letter of the last name of the next person. That's M. Oops, now here Excel is not picking this up. In these situations, what I would do here is come back here, re-edit, and simply press Enter. And now I'll try the M. Nope, doesn't work there either. One more time here. Maybe I'll retype it. And now it picks it up. Now, that's not exactly logical that it worked the second time, but I just had to retype it and it works that way. So the Flash Fill command, in this case, worked better. So you can see all kinds of uses for this. Now, there are text strings, functions that you might need sometimes. Here's an example here. And even here, I think Flash Fill is going to work. I mean, if we wanted to pull this data out by way of functions, we can do this. I can type equal. Suppose I want to pull out data from that cell to the left. The function called mid, think of the word middle, although don't take it literally. We're looking at this data, comma. We want to pull out information starting in the 4th position, and we want to pull out 3 characters. So you can look at the data and see that's starting with the Y. Y19 is what we're about to see here. And there it is. But we saw earlier, we can do this manually. So if we didn't have this data here, I'll do it the other way. Y19, next entry, I'll type K. Got it. So pretty amazing with Flash Fill. So it actually takes the place of formulas. The question is, do we even talk about it with formulas and functions? Because it overrides the formulas and functions, or the functions we might have used, I think it's worth pointing out here. So this is a valuable tool, no question about that. All right, let's look at some other functions here too. There's a new function in Excel 2010. And here's a scenario here that you perhaps have run into. Now, I've purposely put in some mistakes in column B, but we want to add up the data in column B. Let me zoom in a little bit. And here's a function trying to do that. And what do we get? because there are errors in column B, we see this. Now, what if I told you there's a function for this? Where would you look? Now, I would be doing you a disservice if I didn't tell you its name, but imagine I'm telling you this, I got a sudden interruption in the conversation, phone call, whatever, and I didn't get to the name. And you've heard about it maybe. You're trying to figure out where it is. Some function doesn't have a good workaround here. So what are we going to do? Let's go to the Formulas tab. We'll track this down, won't we? Now, what kind of a function is this? Not a financial function. Date, time, no. Lookup reference, maybe. Math and trig, well, maybe. Statistical? Let's go to statistical. Well, good luck finding it. You're going to be looking here forever, and you'll never find it because it's not there. It's under math. That might be a halfway decent guess. And here, too, you're going to have to start looking at these one by one. Does one of these words jump out at you? Take a look at aggregate, for example. Now, the description returns an aggregate in a list or database. Somebody at Microsoft should know that you don't define something by using the word in the definition. Didn't they teach us that back in grade school somehow? Aggregate, this is the one we want to use. Returns an aggregate in a list or database. Okay, let's type this. Equal AG. You'll see it right away. Well, you can see it right now even. There it is. Tab it into place if you prefer. And look what pops up. 19 different entries here. Now, if you've used a function called subtotal, you're familiar with these. They're in an alphabetical order up to a point, but then they added more. So it's if we wanted to do a sum, we put in the number 9. How logical is that? Well, at least you can see it here. We could tab it into place or click it, whatever. If it's an average, it's 1 and so on. So we'll put in the 9 right there. Comma. But here's where it gets interesting. There are 8 choices here, and they're probably difficult to read for you right now, but one of these, ignore error values. Another one, ignore hidden rows and error values. Another one simply ignores hidden rows, and there are other variations to ignore nested subtotal and other aggregates that you might be using already. So in this case, we want to ignore error values. We put in a 6. Now, again, none of these are intuitive, but at least we got a pop-up here that helps us. So we want to add, we want to ignore, that's what the 9 means, that's sum. The 6 means ignore the errors, comma, and finally, what is it we're trying to tabulate here? Where's the data we're looking at? We can either highlight the cells, or in this case, we'll just click column B, and we will get an answer now. There it is. So the aggregate function used here, the 9 means sum, the 6 means ignore errors, and we're looking at the data in column B. So there it is. Average, same idea over here. I could actually, well, I'll just retype it. Equal aggregate, left parenthesis. We want to do an average. That's a 1, comma, 6 to avoid the errors, comma, B, and so on. If we want to get the highest, I should have said highest instead of high, but we'd use max over there. And as you're typing these, unless you use that list often, you kind of forget what comes next. If you're doing a max, that's going to be the number 4. So when you're seeing these later, at a later time, unless you've used these a lot, you always have to kind of jump in and figure out what the number means. So it could be better. I'd like to maybe somehow see the word sum or AVG or something in there to remind us what's going on. But nevertheless, this is the workaround, and it's really handy because in prior versions to work around these, you would have had to use something called an array formula, which we're about to get to. So that was new in Excel 2010 and available, of course, in Excel 2013 right here. A new function in Excel 2013 we've seen already is formula text. Now, I wouldn't really use it here, but we can certainly do that. And again, I said that wrong. It's formula text. A new function in Excel 2013 we want to use here, if we'd like to display the formula, is equal, and there it is right there, formula text. Again, handy for documentation purposes. So that's the formula being used right there. In a different worksheet, it might work a little bit better. Here's a worksheet here that has some formulas in different places. Now, a lot of these wouldn't be necessary, but maybe, let's see, there's one. I'll just select a few here. And since I want to use these next to these cells right here, I'm not sure if all these are formulas, but we'll see. In fact, some of them are not. I'll just type equal FO. There it is. Tab it into place. Left arrow. Control Enter. So we see the formulas for all these where there's a formula. Now that's not a formula if we just delete it, and either of those two. So, you can use that for documentation purposes, and that might work in some situations. It looks a little flaky here because the worksheet itself is pretty disorganized. But nevertheless, that's a valuable tool. Let me actually undo these because the other new function I'm going to use in this same worksheet is called isFormula. And the ideal use of this is going to be with conditional formatting. Now, rather than, first of all, let me remind people that if you do want to know where the formulas are in a worksheet, you can click on a single cell. That's important. Click on one cell, go to the Home tab, far right button, find and select, choose formulas. It highlights the formulas, or the formula cells. And you might want to add a color or you might not. But let's select the entire worksheet, click on the upper left, something like that. And go to conditional formatting. This is on the Home tab. And create a new rule. Use a formula to determine which cells to format. And here's the formula. Equal isFormula. Left parenthesis. I'm going to use cell A1 since currently it's the active cell. That's the one I use, A1. So is this formula? When it is a formula, and by inference what this means is every cell that's been selected, in this case the entire worksheet. When it is a formula, I want to use a format here, and of course I can use any combination of number, font, border, fill being the most obvious maybe. I'll simply make the cell be green, whatever green I want. Light colors work best. So click OK. So, and unlike the feature that we could have used earlier where we selected the formulas and then made them a color, here it's dynamic. So if, for example, here, I don't know if that cell's used elsewhere, but if I simply delete its content, it's no longer green. Let me undo it. If I write a new formula here, simply using some other data, it's going to turn green. So it's dynamic. And so as you work with the worksheet, and this is only applied to the given worksheet, of course, and we don't see any formulas anywhere to tell us this is going on. This is a feature of conditional formatting using that new function called isFormula. And you probably wouldn't use it in, I don't think, any other way. I mean, I could click here and type, isFormula or equal isFormula. It says false. That's not a formula. But if I refer it to cell B7 instead, it says true. So, it might have limited use otherwise. Here's a worksheet here where we're calculating the number of units sold and a unit price. We've got some order numbers. We don't care about those right now, nor the product numbers really. But we've got a calculation here. Oops. But we've got a calculation here where we've got the totals. So the formula right here, pretty straightforward. We're simply multiplying the two to come up with the total. Now, in some scenarios or in some situations, we don't even want to have the interim totals. Just give us the grand total. So here's what we'd like to do. We would like to add up all of these times all of these, one by one. In other words, take all those calculations, 72 times $52.99, the 18 times 62 and 29, take all those products and add them up. If we try this and press enter, we don't get an answer. However, and this sounds like I'm making it up almost, if you press Control Shift Enter, as I'm doing right now, we get an answer. And that's the same answer as we saw right here. We didn't need the interim totals really. Now here's something else that's strange. I'll click back here. Look in the formula bar. The formula is embedded in braces, but we didn't type them. Is he making this up? No, I am not making this up. What's formula text going to show us here? Oops. There we go. It does display the braces, as they're called. We don't type the braces. We press Control-Shift-Enter. Now, there are some specialized cases where you do need to type them, but not the outer ones. Sometimes there's some inner ones more involved. But that's what we've got right there. And that's the same total as this. So we could get rid of these numbers. I'll just do it at least maybe temporarily to show you. We still have a correct answer out there. We didn't need those interim totals. Now, of course, in some situations you might want them, but so I'll put them back. But let's go a step further. By the way, in this case, there is an alternate function that we could have used called sum product. It would have worked, but we're not using it. Now, let's take a different case, though. We've got some items, we got an order date, we got a shipping date, and this is how much time, this is the time elapsed between ordering and shipping. And that average, the average amount of time it takes between the order and the shipping. Now, this is a scenario where the items that are ordered require some assembly, a good deal of assembly, and some packaging before they can be shipped. So let's say these are somewhat reasonable numbers. Some are too high maybe, but nevertheless, we've got an average at the bottom right here. So let's see what's going to happen here. Now, I'm going to actually take this information here and bring it up to the right so you can see it a little bit better. Put it right here. Okay, so here's what we'd like to do. Equal average of all of these dates here minus all of these dates. And here too, if I press enter, we're not going to get the correct answer. But in some cases, you get a believable answer. Now, that probably isn't that believable if you start looking at the numbers, but nevertheless, there could be times when that seems to be right or at least close. It wasn't quite close enough in this case. But here too, well, we got to remember Control-Shift-Enter. And that's the same average we got here in the same kind of situation as before, where we really don't need the interim totals. We just want to know the average elapsed time. So that gives you a little bit of insight into this. But let's take this in a different direction. There's a different worksheet here. And as we look at this, we can see here's 2 David Adams. Well, it's a common name, same department. Oh, same building, same social security number. We got a problem here. Everything's the same. We've got duplicates. Now, many of you know, there's a great feature introduced in Excel 2007. If we had this situation, what would most of us do? We go to the Data tab, remove the duplicates, and Excel would get rid of those rows in short order. And that's what most people, I think, most of the time would want to do. But on the other hand, sometimes you want to know what has been duplicated. So I'm going to set up a formula. Actually, I could start it right here and then copy it up and then down. It's good to do these when we see the actual data. So here's where what I'm going to start here. Maybe I'll start with this one. Equal if, and here's what I'm about to say. I'd like to check to see if, I use the AND function outside of this, if this cell is equal to this one, comma, and this is equal to this, comma, and this is equal to this. Now, I'm only going to do a few of these, but you get the idea. I'm going to have to do this all the way across. This equal to this, and so on and so on and so on. Now, you might make the case for saying, well, if 4 of them are the same, including Social Security, you've got a duplicate. Let's just stop this. But if I were to do this all the way, I'd have to continue doing this all the way out into column L, just to make sure that it was a complete duplicate. And you can see and imagine how long that's going to be. So why don't I just for the moment, I'll put a space in front of it and press enter just to kind of leave it there. Here's a different way to approach it, and I'll just start it in the next cell down. Equal if and. Now, here's what I really like. Here's how I'd like to say it. I'd like to take all of these at once. This is B5 all the way through, out to the right there, L5. If B5 colon L5 equals, and I'll just move down again, B6 through L6. Now I might as well just type the rest of this. Yeah. Now, and that's an L, by the way. I'll use a capital and make it a little more visible. Okay. So what we're about to say by way of an array formula, if one by one, if B5 is equal to B6 and C5 is equal to C6 and so on, all the way out into column L, if all of those are true, comma, let's call it a duplicate. I'll just put it in DUP. We got a duplicate. Otherwise, it's unique. So, comma, double quote, unique. Double quote, right parent, enter. Okay, something was off there. I have to double check it. Let me make the column a bit wider here. Control Shift Enter. I didn't follow my own advice. There we go. I'll double click here. Now eventually we'll see we're going to have other duplicates. There's one right there. Juan Bishop. Now, as we look at that formula, it's an array formula. You can see in the formula bar it's in braces. Now, the formula I started earlier, I didn't really finish, but you can imagine how wide it was going to be. I only got to column E. And so in the example here, if I were to complete that, and I really don't want to do it because it's way too much typing, but you know, in this example here, look at this. B, C, D, E, and we get F and G and H and I and J and K, now all the way up to here, and then more and more and more and more. It'd be really long. This is much more compact. Now, what's in common with all these is you could say that we're processing data in what might be called a parallel fashion. That's not exactly a strict way to say it, but I think you can see what's going on here, and this can be a real time saver. Now, the other reason this is going to be, by the way, eventually what I would do here once we saw this is correct, I'll just drag this upward, and then everything is in place. And we don't actually probably want to do it there too. Yeah, there we are. Now, this doesn't do anything with the data other than identify what's been duplicated. And sometimes that is important. So we're not getting rid of the data so far here. Eventually we do that, but we're simply identifying by way of these formulas what's a duplicate and what isn't. Let me display that a little bit better here for a second. I'll press Control tilde, and there we go. You can see what's happening. So it's handling all those combinations at once. By the way, the unusual font here is called, this example here, just click one of these on the Home tab. It's called Century Gothic. Its value, if it's important to you, is that you'll use 20% less ink because the letters are thinner. Now, it's not important to me. I don't print that much, but it could be to you. And whether it's laser printer or inkjet, you know, you might want to use this font if you like it, of course. Anyway, that's one of its advantages. Now, I want to move on here because with these array formulas, some other things happen too. There are what we call array functions as well. And here's one we're going to need here called frequency. And this is all set to be used in a chart. Now, here's what happens. The frequency function allows us to say, in effect, I'd like to group these numbers here. In other words, we've got all kinds of salaries here. I want to know kind of quickly how many salaries we've got up to and including 10,000, how many between 10 and 20,000 and so on. So arbitrarily, you set up some breakpoints in a column somewhere. And they could be 7,000 apart or 5,000 or 20,000 or whatever. And you probably want to cover the highs and the lows. But we want to do a frequency count of how many salaries we've got here. And there are almost 600 of them fall into these different bins, as they're called. So we set this up arbitrarily nearby. Now, I've already got a chart set up to work off these numbers. So we're about to see a chart here as well. That's not always necessary. But we're going to highlight all these cells together. Equal frequency, left parenthesis, data array. Where is the data? It's in column B. We'll just click it, comma. The next pop-up says bins array. Here it is right here. I'm not going to press enter. I'll press Control Shift Enter. Now the chart here I thought I had set up, but I didn't. So what I'll do here is simply I want these numbers here to display to the right, so I'll simply put in equal here, Control Enter, And now we've got our chart there. And that can be either visible or hidden. I'll just drag the chart over because the numbers in column E are simply a repeat of the data in column C. So now we see the breakout here. And as it turns out, nobody's below 10,000. There are 5 entries here. Now, every time I do this, unless I've been using it frequently, I'm going to stop and think, what if somebody's right on the border here? So what I can do here, just to bring this out a little bit, and let me put in a new column here just temporarily. I'm going to sort this list to the left over here in ascending order. So in the data tab, click AZ. So we can see clearly here, there are 5 salaries under 20,000. What if I make this one be right on the border? Is it going to be counted in the 20,000 list or the 30,000 list? And it's actually, in this example, it's counted in the 10,000 list. So 1, 2, 3, 4, 5. We've got 6 salaries here. Well, actually, it's right. It's just depicted in this number. So what does this mean? This entry here is all the numbers greater than 10,000 up to and including 20,000. Now, most of the time, you're probably going to, well, depending upon the scenario, of course, you're not going to have numbers that end up right on the border, but that shows you what happens there. And so we see our breakout here. For whatever reason, and it's a little strange maybe, in this list of salaries for this organization, not that many people are in this range here, the 50 to 60,000 range, compared with some of our other ranges that we have out here. Now, if we start this list over again, what if I put in, I'm going to put in 20,000 right here, and then change this to be, well, I'll make this be 30,000. And then redo it. We're still going to get pretty much the same list. Take it down to here. That'll take us to 110,000. Now, it would be a little odd to put in every 8,000, but nevertheless, I could do that just to make a point here. 28,000. Highlight both of those. That's an 8,000 interval. Let's take it down to here. So we'd have a different breakout that way. So you can see different ways to work with this. And the total that we have here, I've got a total here of 589. And how many names do we have in the list here? 590, so -1. So it's counting that. If we somehow did this in a way that we're missing one of our names here, if I made these be a 7,000 interval, we're not going to get an accurate count here because this isn't going to take us into the salaries high enough. So now, what's the total of these entries here? It's 548. So we're not accounting for all of these here. So you want to be careful with that concept too. Now, here's what's strange too. What if we say, let's just delete this? If I try and delete one of these, you cannot change part of an array, but we can delete all of them. So if we really wanted to take this to higher values and have a different interval and maybe every 5,000, we could certainly do that. And of course, you can imagine doing this. Highlight them both, drag down here, something like that. Do it all over again one more time, equal frequency. Here's our salary list, column B, comma, here's our bins array. Control-Shift-Enter, there we go. And we'd have to redesign our chart here too, since I didn't make it, right-click the chart down here, format the axis, and make our maximum here go to a different amount here. Well, it's a little bit faster maybe. Let's just skip over this part because it's taking up too much time. And I haven't done this recently. That's why I'm a little bit rusty on it. But we could easily adjust the chart there to account for the appropriate entries that we got here. 2 more quickies here, too, before we move on to doing a match with these. Here's a set of data here. We've got a line chart showing sales. We'd like to show a trend here. And we could easily do that if we simply were to right-click one of the lines here. I'm sorry. We could easily do this if we right-click the line and choose Add Trend Line, and immediately puts in a linear line. That's equivalent to what the trend function will give us. If we want to put in an exponential line, we could switch it to that. And that's equivalent to the data that we would get if we use the growth option. So I'm going to reverse take these lines out. But if we want numbers to go with that trend line, and these are all set to appear in the chart, I'm going to highlight these cells right here and type equal trend, left parenthesis, and select all the sales numbers here and press Control Shift Enter. And so we have the numbers that give us the line here. So this is a different way of creating a trend line. It gives us actual numbers to use in the chart. And growth will give us an exponential line. So I'm going to highlight these cells here and do almost the same thing except type growth. Left parenthesis and highlight the sales data again this way. And Control Shift Enter. And now we've got our exponential line. So not always necessary, but again, it brings out another aspect of the data that sometimes we would want. As you click on one of these cells, you look in the formula bar, it says growth. It's embedded in those braces. If we happen to double click, we don't see the braces. But every one of these refers to the same set of data. In fact, every one of these cells, as we move down, has exactly the same formula in it, which seems a little strange maybe, but it works. Now, let's go to this match names worksheet that we had seen earlier. And earlier we had talked about the idea here of coming up with an ID number. So let's readjust some column widths here and consider what we're trying to do. I'll make some of these manually smaller maybe. Okay, whoops. Okay, so first order of business is we need a VLOOKUP here, at least it seems like it. And we need to pick up this name Garcia, Juan. But how do we make a comparison with columns A and B together? In other words, what we'd like to do, remember, if this data here is on a different worksheet than here, and we already have other formulas working off of this, let's say we don't have the luxury of realigning and readjusting that source data. We need to come up with a combination here of somehow to do this. So if we start off with VLOOKUP, right away we're confronted with something we can't really do. We can't take this entry, Garcia 1, and compare it with both columns A and B together. So what we might have to do here is to first of all use match. And we're trying to take this Garcia, 1, and match it with columns A and B together. Now, if we choose AB, comma, and then do 0, see if that matches, it's not going to work. Now, what if we try Control Shift Enter? Is it going to work then? Doesn't work there either. Let's pursue this different way. What if we were to take first column A, I'm going to click column A, and then it's the ampersand symbol, column B. Now, and we're doing this, we're putting together the names. That means we're putting together, just looking at Juan Garcia for the moment, we are in that list creating Garcia Juan, G-A-C-R-I-A-J-U-A-N, no spaces. So although this is getting better, it's not going to be there yet. We want this entry here, this Garcia, space 1, to match up with some entry that's coming out of column A and double quote, comma, space, double quote, and column B. And we want this to be an exact match, so we put in 0. Still didn't find it. But what we're trying to do here involves a kind of parallel processing that we saw with these array formulas. So let's keep it the same, but press Control Shift Enter. And now we do have a match. It's in the 6th position, and we can see it. It's in the 6th row right there. So we know that Garcia, space 1 will match up with one of these. So that helps us, and that's valuable information. Now let's embed that within index. because with index, what we're trying to do is we're trying to come up, see the heading above this, we're trying to come up with the ID number. So at the time we're using index, we are only looking in column C, comma, and we need to get to data of the 6th position. We need one more closing parentheses out there, and Control Shift Enter. Is that Juan Garcia's ID number? It is. Let's double click, copy this down the column, check out a few more at random. These are time intensive, and it says Excel ran out of resources. Now, it looks like it did find them eventually. Let's check out another one. Here's Susan Carr. She's right over there. There's an A0094. So these are working. And let me momentarily display that so you can see it too. I'll just double click. So there's a lot going on there. And once again, if you're using match and index for the first time, this is a lot. And on top of it, this is an array formula. It will not work if we simply press enter. And once again, Excel ran out of resources here. Control Shift Enter. That possibly is because I need more RAM on this computer, but there could be other reasons too. Once again, a redisplay of it. So, fairly sophisticated use here. And keep in mind, situations like this often involve matching lists on different worksheets or even different workbooks. And when you're doing that, these formulas tend to look even more complex because, for example, instead of simply seeing an F2 here, or let's say instead of seeing a column C, we might be seeing the name of the other sheet. And we know how long those are sometimes, and then a column reference or an address. And so pretty sophisticated stuff here. And matching, like we see here, can only be done when we're working with array formulas, in this case also along with index and match. Okay, so we've seen a lot of different examples here of different functional types. Let me pause here momentarily. John, how are we time-wise?
Can you hear me?
Yes.
We're at an hour and 50.
Okay. Should I stop now or go on a little
Yeah,
bit
why don't you wind it up? Yeah, we're at great time.
Okay.
And I'll edit the transition for it to be smooth.
Okay. In this session, we've only seen maybe 15 or 20 different functions. I wasn't counting, but I think you can see they're just tremendous tools out here. And it's only by seeing examples that are we able to see some of the rich functionality that's available by way of these many functions. And we don't really have the time or the inclination to go to the Formulas tab and check these out. But nevertheless, from time to time, do check some of these out. You'll be surprised from time to time what you'll find. Just a couple more quick ones here. In a list of data, a large list like this, you may want to know the ranking of the salaries, for example, or the compensation amounts here. So I'll just insert a new column to the left of this. And as you might guess, there is a function called rank. I want to know how this entry compares with all the others in the same column. That's the 502nd highest. Now, in a large list like that, those numbers probably don't mean a whole lot, but the example here, and once again, recognize I'm using an entire column reference. What's the ranking of that? There it is. Double click, we see what all the others are too. This is probably a little more effective in the smaller list, but again, I think you can see how it works. There are some variations on this too, and recognize as you type equal R, and you'll notice this with other functions too, here's a rank AVG, and here's a rank EQ. And you probably want to explore those on your own. But the reason they have these here is that rank AVG, for example, deals with the numbers differently when there's a tie. Now, in the example here, if we've got two salaries that are identical, suppose there's another one that's exactly the same, they will share the 502 position, but there won't be a 503. Now, I could simulate this just briefly to show you. I'm simply going to copy these, and you see that they're all 500, but I'll make this one be more. And so this is 500, 501, 502. I'll make this be less. So there will be no 501 in the list. So in effect, they share the 500 and the 501 position. And here's 502 and so on. If you need to go in reverse order, there's also a new way to do that too with one of the other variations on rank. Now, something else that we can do easily, but it now has a companion is, what's the highest salary here? Equal max, the maximum value. And we're not trying to find out where it is, but just what it is. There it is. And sure enough, there's a min too. But from time to time, you might want to know the second highest entry. And you wouldn't guess at it, although you might run across it in your list of functions. It's called large. And large says, I'm looking at a bunch of data, and I want to know the second highest entry there, or the third or the fourth, whatever number you put in. The second highest salary is this. And as soon as you know this function, you know its opposite, which of course is small. What's the second smallest? Now, I need this about once a year, I think, but nevertheless, it comes in handy. And there's no other way to really get to it other than by sorting and looking at it. So what's the second smallest entry? There it is. We don't know what the smallest is unless we choose MIN. So there are just many, many functions like that you wouldn't necessarily know existed here, and yet they are here. And here's another one too. Not terribly important to most people, but I found a use for it once that I thought was handy. A company's going out of business, perhaps, or they're moving their warehouse, and they've got a bunch of items on hand. 237 of these, 309 of these, and they want to repackage these into the respective boxes and move on. And they want to know how many they're going to have left over after they repackage. So what do we do here? We need to divide this number, say by 16, because 16 of these fit into a box. How many are we going to have left over? Now, there's certainly a mathematical way to do this, but it's really fast to simply use the function called mod. Think of the word modular. It's related to that concept. Here's the number we're looking at, comma, and you could say this is the divisor, and all we want to know is the remainder in this division problem. So divide 237 by 16. How many do we have left over? What's the remainder? And it's 13. Double click will take care of all the others. Of course, in this case, 240 divided by 24 is 10. It comes out even. We've got none left over. That's the mod function. And who would ever guess that's in Excel? Unless you work with numbers a lot, you probably have an instinct it's there. Sometimes you don't. So great tools here. Lots of functions, and we've seen many, many more in this session today. So thank you all for watching. This is Dennis Taylor.